Welcome everyone to another session, Data with Nikk the Greek. And today we're gonna talk about two secret configurations in Spark where you can improve your performance when working with Parquet. So you guessed it probably already, it's about Aggregate Pushdown. And why are those configurations so secret? Because it's just not that easy to find them in the documentation. So in the previous session, you learned about Predicate Pushdown. What's Predicate Pushdown? You have a filter operation and you want to avoid to load all the data into memory in Spark, which is inefficient. So Predicate Pushdown allows you to filter already on file level in Parquet in this case, or in generally in the source, and by that reduce the amount of data which you load into memory. It's faster, it's more cost efficient, and you speed up your performance. And aggregate pushdown is exactly the same, but for aggregates, min, max, count. And remember, Parquet has statistics about your data, like the min, max, and the count. And those statistics gonna be now used to also push those aggregates down to the file level, and by that also speed up your performance. So if this doesn't sound familiar to you, then you should really check out the previous video where we're gonna talk about those details. Just remember two things for this session. Number one, Parquet has statistics, and number two, predicate pushdown or also aggregate pushdown is reducing your input output of your data into memory because we're filtering out data already on file level. And with that, let's get started and jump into VS Code in the Spark UI and discover how Aggregate Pushdown works under the hood. Okay, welcome to VS Code and welcome first of all, as always, to our data set. So as always, we have our favorite data set with an ID column, which is a big int. Then we have a static date and timestamp column and a string representation of the ID column. So we have a number, which is a string, and two more strings, which is always the first and the last character. And that's our data frame, which we first of all want to save. And we jump straight away to Parquet. If you want to follow up the other experiments for Avro, CSV, and JSON, feel free to do so. But we're gonna focus on Parquet today. So as always, we save our data set. And then we already introduce our first configuration. And this configuration is called Spark SQL Sources Use V1 Source List. So basically the story about it is Spark already some years ago introduced a new data source API, and that's a version 2 API. And apparently, all the file formats which are listed in this configuration are basically still running on the version 1 API. So why Spark is doing it, I don't know yet. I want to check in the community at some point. But basically, it just states in the GitHub, that's where I found the configuration actually. It wasn't really documented somewhere, that if you want V1 to be disabled, just take the file format out of this list. And I found a video from the Spark Summit 2 years ago where basically they said, okay, the major benefit of the V2 API is more flexible implementation of new data sources and new features, especially different pushdown feature options. And one of them is, of course, Aggregate Pushdown. That's why we're gonna need it today. And it might be also a little bit more efficient, but it's not really clear. And also, I didn't discover big efficiency or significant efficiency gains. And yeah, with that, let's get started so we can see how we can turn it on and turn it off. So here we have V1, because Parquet in this case is in the V1 source list. What we do here is just loading the whole data set. And then in V2, we just have to empty the list or just delete Parquet. So in this case, I just made it easy and just made it empty. So let's check for the first thing. We are looking today mostly on the SQL tab, what's happening there. So you're gonna see that there are slight differences. So the first tab is number one, you can see that we have scan Parquet, we have the 10 million rows, we have the 8 files which we are saving. So that's basically our data set. We have 10 million rows with 8 files distributed. And we can also see that we don't have any filter operations. We are just writing all the 10,000 files. We can see also that we have a batched, meaning vectorized load, which is more efficient. 4,096 rows per batch is this default. That's where also the 2,448 are coming from. And we don't have any filtering because all our 6 columns are loaded. So now if you're gonna check in the V2, okay, those statistics disappear here. And I mean, we can, under stages, we can find out how many partitions we have and what's the data size. But those other statistics, I'm not sure what they disappeared. Maybe it was too inefficient to calculate them. Also, the number of files would be actually quite interesting to always see. And a second difference which I saw is now it's not having the factor batched true or false as we had here. So it's basically now always a batch scan. And I experienced the same also for Apple, for instance. It seems to also use this batch scan. This hopefully is also like a vectorized version, which is gonna be more efficient. So now let's have a look on the filtering. So what we're doing next is the same for V1 and V2. Let's do a column filtering. So we basically are selecting 2 columns, ID and ID string. And let's see how this behaves. So let's delete that. Let's go here in V1 and V2. And the important thing here is to see here you don't see any difference. So 10,000 rows in V1, but also in V2. The important difference you're going to find in the column filtering, as last time explained, is basically those 2 lines. So you see the output are still the 10,000 rows, but basically the output are now only 2 columns. And that's basically all about the column level filtering. And here nothing changed. We can see exactly the same. And we can of course see that the performance compared to before 0.5 seconds, 0.5 seconds, and before we had 1 and 2 seconds. So we have also a bigger performance, and here we can really assume, okay, not all the data have been loaded into memory. Then you already see it. We have the next use case. Let's do it one last time with V1 and V2 as comparison. So in this case, we are not doing a column filtering. We are keeping all columns, but we are filtering based on the ID. And we are checking that the ID is below 300. So let's go again to our SQL. So what you can see here is our statistics. And now we are seeing something interesting. Okay, only 2,000 rows have been loaded. Why not 300? Well, in Spark, in Parquet, sorry. So in Parquet, we have multiple levels, as you hopefully still remember. So we have the row group. And so in this case, we only have 1 row group because a row group usually is up to 128 megabytes big. And we have 8 files with 80 megabytes. So basically, we have around 10 megabytes per file. So, and within a row group, we have the columnar separation, and then we have the pages, and those pages are roughly set around 1 megabyte big. So, and if you have 1.25 million rows per file, in this case, it seems like 20,000 rows is one page which have been generated based on the logic of Parquet. And that's 5 batches. So if you divide it by 4,096, and this is like the smallest piece which Parquet could return. And then we already saved a lot of data, and then we do the rest of the filtering down here. And how can we also see that this filter has been pushed? We have here a parameter or an attribute which states push filters is not null ID. That's something the Spark is doing automatically, the catalog optimizer basically, and then we have less than ID 300. And if you're using V2, we unfortunately miss all the statistics as we saw before, but otherwise we see exactly the same here, and also here, except of the batch scan, it looks the same. Actually quite interesting. We have now two attributes, a data filter and a pushed filter. I didn't realize before. So that's maybe also interesting, but important for us is that it was pushed down, and that's where pushed filters is important. Okay, now let's come to the new stuff. Let's come to our first aggregate pushdown. So, and for that we have to introduce another attribute. So what aggregate pushdown is doing, so you can push down your min, max, and count. So we talked about it already. And there are some limitations. So count is working for all data types, and min, max is not working for nested and string columns. So, and let's do an experiment here. So let's do a count with this parameter true and without this parameter true. And let's see what's gonna be the difference. So let's go back to the Spark UI. Here we have the count and aggregate pushdown false and true. So you already see the speed is times 2. So with aggregate pushdown, it's way faster. And now let's see, because we are not interested to speed, because also those smaller data sets might have some deviations. But we're interested how much data is coming in, and that's always the most important thing. Speed depends on your cluster, but how much data is coming in really shows how efficient your workflow is. So, and here we already see it. So if you do a count, you would have expected that the metadata is coming in. But here we're getting all 10,000 rows. And then we are doing here our calculation. So we have our local count, as we have 8 partitions, we have 8 rows, so the count per partition, and then we have the global count afterwards. And that's the same what we see here. We see at least something very interesting and helpful. The output is empty. So it seems like it's basically ignoring all the columns and schema there, and only loads the row information, but still it seems to be quite inefficient, even if the Catalyst optimizer is already smart enough to do so. Let's have a look now what's happening if we have aggregate pushdown, and you already see it. Now we would get only 8 rows, and those are the count values of those 8 files we have, because each file has only one row group. On row group level we have the statistics, on page level also, but in this case it's on row group level, and we are getting 8 rows. So basically the local counts are already provided by the file itself, and it doesn't need to do any calculations. And we see it here that the duration of stage code again is, I hope that's true, it's significantly faster, so 1/3 of the time. So that's where we save most of it, and also in the input part, of course. The second thing is, which I also want to show, is we now have here, as we had for predicate pushdown for pushed filters, we also have now pushed aggregations here, and the count has been pushed down. So let me see, is there something else to see? Okay, output, we are only getting the count out of it. And also here you see, we don't get any schema information, but actually the count out of the file itself. Okay, let's have a look on another aggregation. Let's have a look on the max. So let's go back here. Let's search where our aggregate with max is, and let's do the comparison. Let me just check. So here we're doing a comparison again. Aggregate pushdown false, aggregate pushdown true. So let's see how it looks here. And you're gonna see something similar. So here without aggregate pushdown, we are getting the 10,000 rows again. Then we have again a local max, and then a global max. So it's basically the same logic. as with count. So we first calculate the max per partition, and then we are calculating the max of the maxes of each partition. So, and also here, Spark is smart enough. So now in this case, we have the max of one column, that's ID in this case, and Spark is smart enough to to already do a select statement for us to only load the columns which are needed. So it's always better to explicitly write the select statement, but the catalyst optimizer automatically identified I don't need to load all the columns because I'm only interested into the max of this column in this case. So now let's have a look again how it works with Aggregate Pushdown. So we're getting 8 rows, and here we can see, okay, 8 rows are there. We don't load all the data. We also have a higher performance. I hope here again also roughly one fourth in this case for the cold stage code again. And also in details, you now see we have the pushed aggregation for this. And I mean, you might be asking yourself, why is Spark not promoting this feature, or why even after 2 years? I checked the PR was roughly 2 years, end of 2021 ago, actually 2.5. Why aren't they pushing it? And my assumption is there are still some features which have to be added where people might expect to be. And to be honest, I already expected that this has been already integrated years ago. But surprisingly, also Delta did this aggregate pushdown implementation just recently. So it seems there's still some way to go regarding features, and that's what we're gonna see in the next experiment. So let's do now a combination. Let's filter the data and do also a count of it. And we already know each file has 125,000 rows and the IDs are sorted. So that means if I would filter based on ID smaller than 125,000, it would be only one file. And on file level or row group level, we have a statistic. So I would guess this would work, and it would do an aggregate pushdown. So let's check it out if I'm right or wrong. So let's go down here, and yeah, we already see it. It doesn't seem to work. It doesn't seem to work. So we get here 125,000 rows, and also when we're looking here into the plan, we see there are pushed filters, but no pushed aggregations, unfortunately. So apparently combining filters with a count doesn't work. Let's see if it works with a max. Unfortunately, also no. We can see, okay, the filter is pushed down, but no aggregate pushed filter. And just for you to not wonder, where's the 124,999 smaller one, 1.25 million, the same as 1.24999 million, smaller equal. I thought this might change anything, but apparently it doesn't. Okay, so why is the case? Also, this is another restriction, unfortunately, of this feature. This might be also another reason why they haven't set it to true default yet. It only works with partition columns. So let's create a partition data set. So what I did here is I repartitioned it based on ID last, because otherwise partitioning would create too many small files. And then I partitioned by ID last. And what partition is basically doing, it creates a folder with the ID last. So you're gonna have a folder. Actually, let me quickly show this. So if we go to Spark data, where I have my partition data set, so basically it creates those folder structure. And as we have 10 values out of it, it creates 10 values, and then we have here our Parquet parts and CSV files in there. So that means we have 10 Parquet files with equal size in this case, luckily. Exactly. And then let's first of all do a simple filtering just to see what's happening there. So we're gonna go back to the Spark UI and we do okay, let me just shortly check Parquet row level ID last. Okay. Okay. Here we have it. So here already you can see it. In this case, we did a filtering based on ID last equals 1, so a string, and we get only 1 million rows of the 10 million. So there it already seems like this is working. And now let's see where we find it. Here we found now partition filters. So that's something new for us. We still get all the values because that's what we are not filtering out, but we're getting the partition filters. And now let's go into the final. Now we finally do a filter on a partition column, and we are doing a group by max. So basically we're getting the maximum of the ID column, which is this value here. And let's go and check out what's happening here. So tada, there is something good happening now. We are only getting one row. That's already nice. And when we are getting here to the physical plan, we can see our partition filter, which is ID last equals 1. And at the same time, we also see our pushed aggregation. So there we finally managed to do a filtering and an aggregation push of the maximum down to the Parquet file. So that means we have the limitations of aggregation work only with partitioning, and the max-min works not with the nested columns or string columns. Those are basically the two limitations which we found. All right, let's summarize what we learned today. So we learned that filter and select pushdowns work on all data sources. So we select pushdowns, I mean column level pushdowns, so filtering columns out. Aggregate pushdowns are not working in JSON, CSV, and Avro, so we didn't deep dive into it, but it's just not working, at least based on the current configurations. And also those files also don't have any statistics which you could use there. So probably they might have also to figure out some other concept if they want to do it. Then activate aggregate pushdown for Parquet with those two configurations. So it seems like it's still in development, or I assume they extend it or they want to add new features. That's why they turn it off. But also like the, let's call them secret configurations where you can start using it. There are also some limitations, and this might be the reason for the configuration, that no nested columns are supported right now, even if Parquet files are supporting statistics for nested columns, and also string columns for min and max are currently not supported. For count, you don't have any limitations. And the filter and aggregate combination is right now only supported with partitioning. That's something which really surprised me, because at least on file level or row group level, you also would have the statistics. So if someone creates a filter which meets exactly the boundaries of a row group, for instance, or the whole file, why not having statistics? At least Delta has this now. And well, aggregate pushdown can speed up your performance significantly. We saw already in our small files that around 50% or even 60 to 70% if we looked at the code stage codegen in performance improvement, and that's pretty cool. And well, regarding the data source API v2, it seems a little bit unclear if it's more efficient than v1 in our experiments. And also the interface seems different, and the batch scan is now always on, which might have some benefits, but I couldn't figure it out now in our experiments, and also like by looking around in documentation. So let's see what's happening there in the next months also on Spark side.
And with that, thanks a lot for watching today. As always, subscribe if you like this channel and you want to see more videos. There's gonna be a red button on the right below here where you can click on it and stay tuned for the next video. Feel free to comment and challenge and like as always, and we see each other soon.